Hi, this is the question from JEE Main 2026, Shift 1, held on January 21. And from in this question, it's actually E is equal to epsilon 0 sine omega t, omega 1 t plus sine omega 2 t. So there are two omegas here. One is omega 1, which is equal to 3 into 10 raised to 15 hertz, and the other one is omega 2, which is 12 into 10 raised to 15 hertz. It's incident on a metric surface of work function 2.8 electron volt. So that is the minimum energy required to eject electrons from the metal surface, and the maximum kinetic. So here the question is what is the maximum kinetic energy of the ejected electron, and what is that approximate value? So we have omega 1 is equal to 3 into 10 raised to 15 hertz, and omega 2 is equal to 12 into 10 raised to 15 hertz. The function is given as 2.8 electron volt. So here we have the electromagnetic wave with two different frequencies, angular frequency. So we have to take the maximum one. So the maximum one is required because we need to find the maximum kinetic energy. So the maximum one is omega 2, which is 12 into 10 raised to 15 hertz. We know that the energy for an electromagnetic wave is given as E is equal to h nu, or h cross by 2 omega, that is h by 2 pi into 2 pi nu. We know that the h value, h is equal to 4.13 into 10 raised to minus 15 EVS, electron volt per second, and we can substitute that value over here. So which is equal to 4.13 into 10 raised to minus 15 by 2 pi into omega, which 2 pi nu is equal to omega, which is actually the omega 2. We can substitute that value over here, and when we solve it, we get so this one into this one will give you 50 almost, and 50 divided by 2 into 3.14, which is 6.28. So 50 divided by 6.28, you will get 8 point something, so 8.1, and this one 10 raised to minus 15 and 10 raised to 15 get cancelled, electron volt, and 8.1 or something, approximately 8.1 electron volt. So now we have to subtract the work function from here so as to get the maximum kinetic energy. Therefore, maximum kinetic energy is equal to E. So this is energy E minus the work function, which is W0, that is 8.1 minus 2.8 electron volt. So that's 3, 5 minus 2, which is 7 minus 2. So approximately 5.3 electron volt. So the closest answer is given as 5.4 electron volt. So that is your answer.